Hello friends, Neo Toy Story here with my latest project for Neo Toy Lab. This was actually something that I started a really long time ago, but I lacked the sufficient technology to make my vision a reality. So now that I have a decent 3D printer, I'm basically able to create this to my own specifications. And what you're looking at here is a 3D printed magnetic button, and that uses these neodymium super magnets. These are standard, and you can get them at a lot of different places. I got these at my local hardware store. They measure 8 by 3 millimeters, and they're quite strong normally. In fact, if you were to have them not inside of this enclosure, it would take several pounds of force to separate them. As it is, these are still quite strong. Probably takes, I don't know, 3 to 4 pounds, I would say, to separate these. And I created this little chart here to show the issue there, where basically the magnetic field strength declines precipitously depending on how far away the magnets are from each other. The closer they get, the stronger the field. And I determined that my 3D printer can only handle pretty reasonable tolerances. And so the first problem I had was I tried printing 0.8 millimeter offsets on the inside, which is hard to explain, but I'll try to do my best. See that little ledge inside? The magnet basically goes in there like this. It pops in, and then the ledge retains it so that it doesn't come out. And obviously I wanted that ledge to be as small and thin as possible so that I could get the maximum magnetic field strength. But the problem was I made it too thin, and you can actually see that it didn't fully print all the way around because the filament itself was basically just too thick to form that thin little edge there. So it took me 4 revisions of the original design to create what I think is basically the final version, which is more or less exactly what I wanted, and it hits all the markers for criteria. And I'm just going to go over briefly the issues that I came across. Like this one, I'm almost always, this is a design idiosyncrasy of mine, but I almost always design things as absolutely as small as possible to start with, so I can get an idea of that hard wall of the physical tolerances and limitations that the medium is going to present. And so this was way too small. The holes actually go through, but as you can see, they're just too small really for a standard needle and thread. I did kind of like the star design, but in the end I felt like it was just kind of meh and not really too exciting. And also I wanted it to look more like a conventional button. The cavity inside was 3.2 millimeters thick. So in theory, that should have been enough to account for the tolerances of the magnet. However, it was not, and the magnet did not fit fully inside the cavity. It was just a lot of background information. I'm sorry if some of you will find this boring, but you can see that there wasn't enough space for the magnet to fit inside there. And also, the closure mechanism that I designed, there's little cavities and tabs around the edge. Those were also too small, so it just everything was just too small is what it came down to. The version 2, there weren't enough holes, and this was something I didn't realize when I first created the closure design, that I could actually fit more holes in there. So that was just kind of an incidental flaw. The cavity was too large. I overcompensated when I tried to fit in the magnet, I wanted there to be plenty of room to get a nice tight seam, and I made the cavity 0.2 millimeters too large, so it actually, while it closes and gives you a perfect seam, there's a little gap in there and the magnet can actually move back and forth, and I didn't want that because there's no reason that I can't get perfect tolerances. And then the edges are just too sharp. I didn't like that. It's uncomfortable. If this is on clothing, it can be an issue. One of the nice benefits about this design is it doesn't need a brim when you're 3D printing because there's enough surface area down here to stick to the build plate. So I moved on to version 3 and made all the changes that I felt like I wanted, and so I made it nice and smooth and round. You can see it's way too thick, but I'm still experimenting at this phase. And I was able to add more buttonholes. My original intent when I started out on this was I wanted 6, because most buttons have anywhere from 2 to 4 buttonholes, but I wanted to have a lot because I don't like my buttons to come off ever, and this is a slightly different design. The offset, this is something that really was interesting because I made the that internal ledge thicker. You can see how thick it is from the surface of the magnet top to the outer surface of the button. It diminished the magnetic field too much, so that where I had 2 of these buttons together, they actually it was very weak attraction because I wasn't getting enough magnetic field strength, and that was 1 millimeter. That was way too thick, but it was bigger than the 0.8 millimeters that I started out with. Oh yeah, and then a really big flaw that I didn't account for, and I'll show you this. This is something that I only realized after I sewed a button onto my clothes to see how it would work in the real world. Now, the thread actually sticks up above the surface of the button, and that created an additional offset. So in addition to the millimeter inside and then the thread, 0.2 to 4 millimeters on the top, it was significantly screwing up the magnetic field strength. So my last sort of multi-revision, version 4, I put these nifty little notches in here so that the thread stays below the top of the button surface to maximize magnetic field strength. And then I lowered the internal ledge down to 0.5 millimeters, which I found out I could pull off rather nicely if I changed the shape from a sphere or a circle to a hexagon, and also made it a little bit wider around the edges. The downside to this design is that it requires a brim to print because now there's not enough surface area for it to stay adhered to the build plate. I mean, most of the time you can get away with it, but I was noticing it was failing around 50% of the time, and that was too often. So finally, I had basically the complete version. It's a millimeter thinner. The notch gives you, total magnetic field strength in addition to the thinner edge, but a brim is needed, sadly. So I'm gonna just do a quick demonstration of how the button actually works here on my prototype garment. So basically, you sew one to the underside and one to the overside, and they just snap together. This is about maybe 1 to 2 pounds of magnetic force, mainly because of that millimeter offset and the addition of the thread standoff. That was not good, so that really precipitated the whole revision of the design. But this still was functional on this garment, so I felt like that was kind of nice that I was already kind of succeeding. But anyway, yeah, I've experimented with magnetic enclosures in the past, and I just think, like, why wouldn't you use magnets with, especially super magnets, with modern garments, because they're better than regular buttons or zippers. And I mean, for certain applications, not every applications, but it adds a lot of diversity and potential to fashion. Just a different enclosure type that doesn't require tedious fastening and can be opened and closed rapidly. So now that I've got this design done, what I'm going to do is upload the latest version of printables when I have a minute, and I'm going to sew 10 of these buttons, which is a pair. You know, this is a button essentially, or whatever you want to call it. I haven't come up with a clever name for it. Magnet button seems good enough. Magnet snap, I don't know. The real value in the design is just that it's a way to safely and accurately contain the super magnet in this enclosure that allows you to easily attach it to a textile surface. I love sewing. It's one of my favorite hobbies, so this is something that is right in my wheelhouse. Yeah, so next step, put it into full production and on a garment and see how it performs. And I'll maybe do an update video in the future about that. But so far, I thought you guys might enjoy just sort of a behind the scenes look at one of my inventions and the development process. Thanks for watching. Take care.